All right, so we're in section 11.3. Maybe that's what made me think of it. Not that any math people in the building would set it on fire. We have better ways to solve math problems. Do you know how many math teachers it takes to screw in a light bulb? None. They assign it as homework. Do you know how many college students it takes to screw in a light bulb? Just one, but it takes them 5 years. Do you know how many school administrators it takes to screw in a light bulb? What's wrong with the old one? So what? I don't complete that loop, and this little one is extra, so I don't mean to write it backwards. It just kind of looks that way. It's an optical illusion. All right, pyramid.
Oh, wow.
So what we're going to do is talk about what a pyramid, parts of a pyramid, what it is, and then we'll talk about our formulas. So a pyramid is a polyhedron. Do we remember what a polyhedron was? It's a solid shape, 3D shape made of parts of intersecting planes, so the sides are flat. So a pyramid is a polyhedron with, I'm going to list a bunch of parts. A base, which is a polygon. So the base of our pyramid can be any polygon. So triangular pyramid, square pyramid, rectangular pyramid, trapezoid pyramid, hexagonal pyramid, all these different parallelogram pyramid, all these different shapes can be pyramids, made into pyramids. It has 3 or more lateral faces. Lateral just means side. I don't mean side. So what shape are the sides of a pyramid? These are triangles. And why do we say 3 or more? So what's the smallest polygon that we have? Triangle with 3 sides, and we put another side on each of those, so we get 3 lateral faces. We have a vertex. The point, that's where the lateral faces meet. We also have what we call a base edge, and we'll draw a picture here in just a second. Base edge, and a lateral edge. So just a list of our parts. So let's draw a picture here. Oh, I forgot to load this first time this year that I'm actually moving. The way I usually draw a pyramid is just draw whatever shape your base is. So if you want to draw a rectangular pyramid, there's my rectangle that's the base. Draw a dot up there, and then just connect your dot to your corners, and you have a nice pyramid. All right. So I have some nice drawings here. Geometry, 3D figures. And I'll use that pyramid. So there's my pyramid. We're going to label all of our pieces here. So the base is here. This is our vertex right up here at the top. The triangles are lateral faces. I'm going to I'll label this one. The triangle is the lateral face. This segment is a lateral edge. And this edge would be a base edge. And there are a couple of other important pieces that we need to keep track of with our pyramid. Now, our pyramids are named by the shape of their base, just like a prism. We name them by the shape of their base. So this would be a square pyramid. It would be square or rectangular, depending on the dimensions. We're going to draw in the altitude or the height. So the altitude goes from the vertex to the base at 90 degrees. And we also call it the height. I'm going to say the altitude / height. From the vertex to the base at 90 degrees. Most of the time we'll call it the height. We use the altitude and height kind of interchangeably. There's one other piece that's important on pyramids. If we draw from the vertex to the base edge, we call that the slant height. And it intersects the base here at 90 degrees. So our slant height is the vertex to a base edge at 90 degrees. And the slant height is important because this is the height of the triangle that makes up that face. And the other piece that's going to be very important is we're going to connect the altitude to the slant height, and we get a little right triangle inside our pyramid. So on my 3D shape here, the altitude or the height is the rod here in the middle. The slant height is the red one along the front on the face of that triangle. And then the line that I drew goes from the middle of the base on this particular one to the edge of the slant height. So you get a nice right triangle made by the altitude, the slant height, and the apothem of the base. Here's a hexagonal pyramid, same thing. There's a slant height in red there on that triangle. Altitude is the rod, and then the apothem, the little red line there, connects the altitude and the slant height to make a right triangle. And those right triangles are going to be important. All right, are we good with these parts so far? So a little more to keep track of than a prism. A regular pyramid means that we have a regular polygon as a base. So we would have a square. We would have a regular hexagon. We'd have an equilateral triangle. So regular pyramids means that all the base edges are the same length. If we have a right pyramid, that means the base, the height goes to the middle, the altitude goes to the middle of the base. I'm going to say altitude hits the middle of the base. And when we talk about the lateral area, that just means the area of just the triangle. The triangle, I'm going to say the triangle side, because the base could be a triangle. The lateral area just means the area of the side of our pyramid. All right, questions on our parts and our concepts here. All right, so what I want to do is draw a net for a pyramid, a square pyramid, to talk about where the formula comes from, kind of like we did for prisms. So here's my base. And my sides, my lateral faces, are all triangles. So I'm just going to draw triangles on each of the sides of my base. My drawing might not necessarily be perfect, but it'll be pretty close. And it doesn't have to be perfect to get the idea. So there's my net. If I folded that up, if I drew it just perfectly, all the top, these vertices of my triangle would be the vertex of my pyramid. So this is my base. And I'm going to draw in the slant height. There's the slant height, is the height of that triangle. And it meets the base edge at 90 degrees. And we usually use L, a lowercase l, a script L, for the slant height. And let's say the side length of the base for the square pyramid is S. So so the surface area is going to be the area of all these added together. So how do we find the area of one of these triangles, one of the lateral sides? What's our formula for the area of a triangle? Base times height divided by 2. What's the base of this triangle? The side length, S. So the area of a triangle equals the base, S, times the height, which is the slant height, divided by 2. The lateral area, the area of all the triangles, how many of them do we have? They're all the same, right? 4 of them. 4 times S times L divided by 2. Well, if I multiply 4 S's, there's S, 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 S. What, if I add 4 S's together, what do I get here for the base? 4S, which is this side plus this side plus this side plus that side. What is that for the base? When I add all the sides together? The perimeter. This equals the perimeter of the base times L. 4 times S is the perimeter of the base, divided by 2. And the total area equals the area of the base plus, and we usually write it the other way around, L times P divided by 2. The area of the base plus L times P divided by 2. Well, this L times the perimeter of the base gives us our lateral area, the area of the side, and we just add it to the area of the base. That's where our formula is going to come from. It's just adding up the areas of these triangles and adding that to the area of the base. And we could do the same thing for any number of sides. On our base, we'd get the same thing. Because we add up, if we had a hexagon, we'd have 6 triangles. Well, 6 times the side, one side of the hexagon would be the perimeter of the hexagon. So that's where our formula comes from, is breaking it into a net. You can always break your pyramid into a net to find the surface area. You can make a little drawing like this to find your surface area. All right, so let's write down our formula. Surface area of a right pyramid. And notice we're saying for pyramids, just like we did for prism, our surface area formulas work for right pyramid. The surface area, SA, equals 1/2 LP plus B. Square root. L is the slant height. P equals the perimeter of the base. Just like our formula for the surface area of a prism, and B equals area of base. And we can think of this as the lateral area, the area of the side, plus base area. And it's important, one thing that students often do, the mistake they make, the 1/2 only goes with this part. It doesn't go with the whole thing. So we don't divide everything by 2, just this first part. If it helps you remember, you could write it as LP over 2 plus B. So that the 1/2 only goes with this part. So there's our formula. We need to know slant height, we need the perimeter of the base, and we need to know the area of the base. The area of the base depends on the shape of the base. Area of the square, area of the triangle, trapezoid, etc., etc. Are we good? Okay, let's look at a couple of examples. And then we'll talk about cones. So I'll draw a picture of this one. I won't use my fancy picture. There's my pyramid. And it's a square pyramid. And our problem says the base edge equals 8 centimeters. And the slant height equals 12 centimeters. So I'm going to label my parts. If they don't give you a picture, you can always draw a picture. There's 8 centimeters. I'm going to draw in the slant height there. That's 12 centimeters. All right, do we have everything we need for our formula? 1/2 LP plus B. So if it helps to make a list, make a list. What's L? Slant height. 12 centimeters, it tells us that. What is P? What's the perimeter of the base? 32, and how did you get to 32? 8 times 4, it says that base is a square, so all the sides are 8 centimeters. 8 times 4 is 32. What's the area of the base? What is it? Someone said it. 64, 8 times 8. Length times width. Plug all that into our formula. 1/2. 12 times 32 plus 64. 1/2 only goes with this part. So I get 192 when I multiply this out, plus 64. This is the lateral area, the area of the triangle. This is the area of the base. Add those together and I get 256 square centimeters. It says the base is a square and one side is 8. We have 4 of those. 4 times 8 is 32. Excuse me. All right, let's do one that takes a little more work. Questions on what we did there? Okay. Here's our example for this one. I'm going to grab this picture. So another square pyramid. And we're going to say this is 9 inches. And I'm going to draw this in. This is 8 inches. And we want to find the surface area. Do we have everything we need here? We know the surface area is 1/2 LP plus B. Do we have the slant height? No, what do we have? We have the altitude, or the height of the pyramid. Let's draw in the slant height. There's the slant height, right down the front of the triangle there. So that's L. And we remember that we can draw a nice little triangle there. That is a right triangle. So let's redraw that little triangle. So here's my slant height. Here's the other side that I drew. And here's the altitude, or the height. And we know that's 8, and that's a 90-degree angle. There's L. Do we know how long this is? 4.5, because the altitude, or the height, hits the square right in the middle. So that's 4.5. All right, so here we have this triangle. What can we do to find the slant height now? What lovely thing do we have that always works with right triangles? I'm going to give you a hint. This side is A, this side is B, this side is C. What always works for a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. Always for right triangle. We have 2 sides, we can find the third side. So we know that L squared equals 4.5 squared plus 8 squared. That'll let us find L. So L squared equals 20.25 when we square that, plus 64. L squared equals 84.25. What do we do to find L now? get rid of that square root. So L equals, when I take square root, I get 9.18. Now that we have everything that we need, I'm going to say this is a square pyramid. Now aren't we back to doing the problem just like we had on the last one? We set this pyramid on fire because we know how to solve it. Yeah? The altitude hits the base right in the middle. So since it's all the way across 9 inches, all the way across, halfway across is 4.5. All right, so our surface area, plug into our formula, 1/2. The slant height, which we found, 9.18. What is the perimeter of the base? If this is a square. 36, 9 times 4. Each of these sides is 9. Plus the area of the base. The square. So our area is 81. So our surface area, when I calculate this out, 9.18 times 36 divided by 2, I get 165.2 plus 81. This is the lateral area. This is the area of the base. And when I add those together, don't have that memorized. 165.2 plus 81, and I get 246.2. Square inches for the area, surface area of that pyramid. So this little triangle inside your pyramid is going to be an important one to remember. That comes up often. All right, questions there? Okay. Cones. A cone is a solid, not a polyhedron. Why is it not a polyhedron? It's not made of polygons, right? It's all curved. Everything's a curve. Not a polyhedron with a base that is, what's the base? Circle. A lateral surface. And the lateral surface is just a curved surface, and we'll talk about what it is in just a second. So our lateral surface, our side, is just a curved surface. It has an altitude or a height. And we find that the same way as we do for a pyramid, from the vertex perpendicular to the base. And a vertex, we also have a vertex, it's right at the top. Right cone. Let me go back up. We also have a slant height for a cone. Which goes from the vertex to the edge of the base. And when we talk about a right cone, the altitude goes to the center of the base. So let's draw a picture of a cone. When I draw a picture of a cone, I usually just draw kind of a squashed circle and a point, and then connect those to the side. So there's a cone. I'm going to grab a different picture here because it has some different parts on it. So there's my picture of a cone. Let's label some sides here. Some parts. Here's my vertex, right at the top. My base is this circle. The circle has a radius. Call that radius R. There's my altitude. And the slant height just goes down the side of the cone here. And notice that right triangle there that we have in our cone, made by the altitude, the radius of the base, and the slant height. So we have a right triangle inside a cone also. And then here we have there's a cone with a base. You like that one? And the volume might be able to go up to 11. Okay. Let's draw. We good with the parts of the cone. So we have a cone with an upright base. Yeah, so the base could be this way, right? There's a cone with an upright base. All right, could go on like this all day. A net for a cone. Now I made the lateral surface of a cone here, so we can see where a net comes from, how we make a cone. So what I did was I drew a circle with my compass, and then I cut a wedge out. So cut a piece out. If I fold that up so these two pieces meet, I have a cone. And there's my base. But I open it up so the lateral surface is a piece of a circle. And I fold up that circle, and I get the lateral surface of the cone. The slant height of the cone here is the radius of the circle that I cut to make the lateral surface. So the slant height is the radius of that circle. And then to make a net for the entire cone, I would have to have a little circle here attached to the edge to make the base. But the other piece of that is that would be the circle that makes up the base. The circumference of the base is the arc length of that piece of the circle that I cut out of the bigger circle to make the lateral surface. So that's going to give us our relationships that we need for our formula. So let's draw a net. Here's my circle. I'm going to draw a dotted circle. Here's the circle that I drew that I made my net with. And what I did was I cut a wedge out of that circle. So let's say this is the wedge that I cut out. So I made my wedge on my drawing here a little smaller. And then the circle that makes up the base of my pyramid would have to be attached there to make my net. And then when I folded up this wedge, I'd get my cone, and this would pop up and be the base. Well, this base has a radius r. This radius of this bigger circle is the slant height, L. This length is the circumference of the base. So that is 2 pi r. Now to come up with the area, we talked about areas of sectors of circles, and we talked about the angles. We can think about this a different way. We could think of this piece that I cut out as kind of a curvy triangle. So the lateral area, the area of this little kind of sort of triangle piece, how do we find the area of a triangle? Base times height divided by 2. What's the base of this curvy triangle? 2 pi r. And the height? If I draw this in there, isn't that L? If I drew the height there, that's just the radius of that circle. The height equals L divided by 2. Those cancel, and I get pi r L. The lateral surface area of our cone is pi r L. And then our base area equals, what's the base area here? The area of the circle, pi r squared. We're going to stop here for just a second. For our formula, we know that lateral area is pi r L, and the base area is pi r squared. We add those together, and we get the surface area of our cone. So let's write down our formula. And we're talking about a right cone. So our surface area SA for surface area equals pi r L plus pi r squared. And this is the lateral area. And this is the base area. It's the exact same formula that we use for a pyramid. The lateral area plus the base area. They're the same formula. We just find the two things in a little different way. And our units are squared. So like cylinders, or I said cylinders are the curvy cousins of prisms. Cones are the curvy cousins of pyramids. And let's make our key here. R equals the radius of the base. L equals the slant height. And I could call this capital B. So this would be the lateral area plus capital B. So B would be the area of the base. I think that's not too hard to remember. All right, questions? Questions on our formula? All right, let's do one example and then we'll be done. So here's our cone. I'm going to draw a cone this time. And I'm going to draw this here like so. So this is 12 meters, and this is 5 meters, and we want to find the surface area. All right, do we have everything we need to plug into our formula? Here's our formula. We can make our key over here if we want. What's the radius of the base? 5. What is the slant height? Oh, we don't have the slant height. What do we have here? We have the altitude. So how do we find the slant height? Pythagorean theorem. This is a right triangle. There's our slant height. Just like the last problem, we can say L squared equals 12 squared plus 5 squared. So L squared equals 144 plus 25. L squared equals 169. Square root of 169? 13. 13, 12, 5 is the Pythagorean triple. So L is 13. Plug that into our formula. So our surface area is pi times 5 times 13 plus pi times 5 squared. Oh, and I forgot to say in terms of pi. So here we get 5 times 13. 5 times 13 is 65 pi plus 25 pi. So in terms of pi, we just add the numbers and leave the pi by itself, just like we'd say 65x plus 25x. So 65 plus 25 is 90 pi square meters. And that would be our answer in terms of pi. Now a couple of things about this right triangle inside our cones and inside our pyramid. Sometimes you'll have to use that triangle to solve for the radius or the apothem. Sometimes you'll use this right triangle to solve for the slant height. Sometimes you'll use it to solve for the height. But you can always use that right triangle to do Pythagorean theorem to do something. And I have a little demonstration here that I wanted to show you that shows a bunch of different right triangles that we can use inside of pyramids. Where did I have it? Here. This takes a second to open. While that's opening, I'll write down the homework. There's our homework. It's ready to go. There we go. No, not quite. All right, there we go. So there is the first triangle that we talked about, made by the altitude, the apothem of the base. There's the apothem of the base, and the slant height. So there's one right triangle that we can use. This shows it with a square pyramid, but it's in other pyramids also. There's another one that sometimes we use, just on the face of the pyramid. This is the slant height, half the base, and the length of the lateral edge. Sometimes you'll use that right triangle. Here's a right triangle inside our pyramid made by the height. We're going halfway across diagonally, and we have the edge length there. So that's another right triangle that you might have to use sometimes. This one we don't use as much, so jump over that. That one we don't use that much. This is the one that we used when we talked about how we find the area of a regular polygon. So we divided the square into triangles. So that one is also one that you can use sometimes. There's another way that we looked at the area of the square, the apothem halfway across the diagonal. All of those are different right triangles inside a pyramid that you can use to get information if you're missing pieces of information. All right? Okay, there's the homework. Stopping